Assalamualaikum warahmatullahi wabarakatuh. So this is my introduction. My name is Ilham Haikal Kamis and my student ID is 2020-8584-52.
Assalamualaikum warahmatullahi wabarakatuh. And hello to everyone. My name is Muhammad Fakrul Haikal bin Johari Pang and my metric number is 2020491828.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ali Iskandar bin Mazhat and my ID matrix is 2020811272.
Hai, Assalamualaikum warahmatullahi wabarakatuh. My name is Aidit Sabri bin Muhammad Azamuddin. My matrix number is 2020601328. So in this video we will present about a topic called application of differentiation in maximum and minimum values.
What is differentiation? In calculus, differentiation is one of the two important concepts apart from integration. Differentiation is a method of finding the derivative of a function. Differentiation is a process in maths where we find the instantaneous rate of change in function based on one of its variable. To illustrate, if x is a variable and y is another variable, then the rate of change of x with respect to y is given by dy over dx. This is the general expression of derivative of a function and is represented as f prime x equal to dy over dx, where y equal to fx is any function. When do we apply differentiation? We can use differentiation to determine if a function that was given is increasing or decreasing. But the question is, what is the increasing and decreasing function? So, an increasing function is a function which increases as x decreases. I will give an example, which is x1 is bigger than x2, so we call that increasing. So, a decreasing function is a function which decreases as x increases. So, if the x1 is lower than x2, so we call that decreasing. Of course, a function may be increasing in some places and decreasing in other. So a point where a function changes from an increasing to a decreasing function, we call it as a turning point. A turning point is a type of stationary point. For example that I gave you is y equal to negative x has derivative to negative 1, which is always negative, and so negative x is decreasing. The second one is y equal to x square has derivative to x, which is negative when x is less than 0 and positive when x is greater than 0. Hence, x square is decreasing for x less than 0 and increasing for x greater than 0. What is the other application of differentiation? The answer is second derivative. We use second derivative to determine the maximum and minimum values of particular functions. So we will go through more deeper about the second derivative in the next slide. Stay tuned.
So right now, I will show you the objective of this question. So the first objective is we need to show the combined area of the garden and the border, which is A equal to 4x plus 270 over x plus 69. So the second objective, we need to show the dimension of the garden will minimize the combined area of the garden and the border. And the last objective is we need to show the minimum combined area of the garden and the border.
So in this slide, I will show the question. The question is a rectangular flower garden with an area of 45 meter square is surrounded by a grass border 2 meter wide on two sides. Let x and y be the length and width of the flower garden respectively. So in this question, there are three objectives that we need to solve. So we will proceed with the objective.
For question A, we need to show that the combined area of the garden and the border is the same as this equation, which is A equal to 4x plus 270 over x plus 69. So, the question has given the area of garden, which is 45 meters square, and we know that the formula of area of rectangle is length times width. So, we can create an equation for the area of garden, which is A1 equal to xy. A1 is the area of garden, x is the length, and y is the width. Next, we need to find the area of border. To find the area of border, we need to exclude the flower garden from the whole area. For that, we create an equation which is A2 equal to open bracket x plus 6 close bracket open bracket y plus 4 close bracket minus 45 to find the area of border. After we calculate the equation, we get this equation, which is A2 equal to xy plus 4x plus 6y minus 21. From the recent equation, we finally can find the combined area of the garden and the border. So, the equation for the combined area is A1 plus A2 equal to xy plus xy plus 4x plus 6y minus 21. So, we replace xy with 45 because the area of garden or A1 equal to xy equal to 45. And also we replace y equal to 45 over x because from xy equal to 45, we get y equal to 45 over x. Calculate it and we get the answer, which is 4x plus 270 over x plus 69. So, it is shown that A equal to 4x plus 270 over x plus 69 is the combined area of garden and the border.
So, question B. What dimension of the garden will be minimize the combined area of the garden and the border? So, in order to find the dimension, we need to find the value of x. So, how to find the value of x? We need to differentiate the equation that we got from question A, which is area equal to 4x plus 270 over x plus 69. After we differentiate, we got 4 minus 270 over x squared. After that, we need to find the value of x when dA over dx equal to 0. That's why we need to differentiate the equation. So after we find the value of x, we got the answer, which is positive square root 67.5 and the other one is negative square root 67.5. So we got the answer, but the dimension will be only one answer. So we look back at the question. The question said that dimension of the garden will be minimized. So the key of this question is minimize. So we need to find the minimize. Minimize is equal to minimum. So in order to determine the minimum and maximum area, we need to use the second derivative. After we do the second derivative, we got 360 over x power of 3. So when x equal to positive square root 67.5, we got the positive value. So now we know that this is the minimum area. So when x equal to negative square root, we got the negative value. So we all know that this is the maximum area. So our objective is to find the minimum area. So minimum area equal to positive square root 67.5. So that's all from me. We got to go to the next question.
Alright, we continue for question C. For question C, what is the minimum combined area of the garden and the border. Actually, we must refer question B for minimum value, which is the question require the minimum value. So we use minimum value, which is 67.5 square root. From that minimum value, we substitute the value into question, and lastly we get the answer, which is equal to 134.7267 meter square. Alright, that's all, and thank you.
So the last one is conclusion. The conclusion that we got is differentiation can be used to find the maximum or minimum value, and all of our objectives has been complete. So that's all from us. Thank you.